Hey guys, welcome back. So we are looking at lesson 21 today, the last one of unit 5 that we'll be doing, cylinders, cones, and spheres. So let's go ahead and jump right in. So the sphere's radius, the volume of this sphere with radius r is v equals 288 pi. This statement is true. 288 pi equals 4/3 r cubed pi. What is the value for r in the sphere? So what we want to take and do is solve this. So we have the 288 pi equals the 4/3 r cubed pi. So right off the bat, we know we can divide both sides by pi to get rid of the pi on each side. So now we just have 288 equals 4/3 r cubed. To get rid of the 4/3, we can divide, which remember, we'll use same times flip for, or we can multiply by the reciprocal. Essentially, they're the exact same thing. So I'm going to write it as times 3/4 times 3/4. So if we take 288 and we multiply it by 3/4, we get 216 equals r cubed. So now we need to find the one value that times itself 3 times gives us 216, or we need to take the third root. So the one number that multiplies 3 times to give us 216 is 6. 6 times 6 is 36, times another 6 is 216. So the radius here is 6. And so explaining how we know, well, everything we just did here. We undid all of the parts of finding the volume to find out what that radius was. And if we reversed it, if we took 6 and cubed it, we'd get 216. We'd multiply that by 4/3, we'd get 288, and then we'd multiply it by pi to get 288 pi. So lots to do with volume here. So volume is your key word for this lesson, volume. All right, the right fit. A cylinder with diameter 3 centimeters and height 8 centimeters is filled with water. Decide which figures described here, if any, could hold all of the water from the cylinder. Explain your reasoning. A cone with a height of 8 centimeters and radius 3 centimeters. Well, if we think about the cone, remember the volume of a cone is 1/3 the volume of a cylinder. So if they have the same dimensions and then we're taking 1/3 of it, there's going to be a lot less there. It's going to be 1/3 the amount. So it won't be able to hold it all. So if we think about it, so solving this, height of 8, radius. So first let's find the volume of the cylinder. Makes it a little easier. So volume equals pi r squared h. Radius here is 1.5. So pi times 1.5 squared times 8. So 1.5 squared is going to give us 2.25 times 8, which gives us 18 pi. So there is the volume of our cylinder. Now, if we look at the cone, like I said, it's 1/3. All of that same stuff. So we'd have 1/3 times pi times 1.5 squared times 8. None of that changed. Oh, wait. Sorry. I read it wrong. Radius of 3 centimeters, not diameter. So, whoops, change that. 3 squared, so this will change it some, times 8. So 3 squared is 9. 9 times 8 is 72. 72 divided by 3, or times 1/3, equals 24. So we'd have 24 pi, which is bigger than 18. So yes, it would fit. Sorry, I read it wrong. I just saw the 3 and 8 and thought it was still talking about diameter. All right, so for number 2, cylinder with diameter of 6 centimeters and height of 2 centimeters. So if the diameter is 6, that means the radius is 3. So we'd have 3 squared times 2 times pi. So we'd have 9 times 2, which is 18. So we'd have 18 pi. So yes, it would also fit. It'd be exactly the same size. And then for the last one there, rectangular prism with a height of 3 centimeters, width of 4, and height of 8. So we'd take 3 times 4 times 8. 3 times 4 is 12, and 12 times 8 is 96. So we'd have 96. Now, thinking about this, obviously we've been looking at 18 pi, but 18 pi, if we multiply it by pi, is 56.5. So this is still bigger. So yes, this one would also work. And then the last one, sphere with a radius of 2. So remember 4/3 pi r cubed. So we'd have 4/3 pi, times 2 cubed. 2 cubed is 8. So we'd have 4/3 times 8, which is going to give us 10 and 2/3 pi. So this one would not be big enough. We'd need it to be bigger in order to hold all of that water. So looking at comparing these volumes and seeing how changing certain values and what values we need to change to hold that same amount, and how we can have several different kinds of containers that'll still be able to hold at least as much as another. All right, if you guys have any questions, feel free to ask.